Welcome back. So in previous lecture we discussed about fluvial landforms like terraces and alluvial fan, and then we also discussed about the fault scarps, back tilted terraces, or we can say alluvial fan surfaces. Now, these are the most common features which you will come across when we are looking for the active tectonic deformation or the manifestation of the tectonic deformation on the surface. Now, apart from this, we also looked at some details of different type of channel patterns, mainly straight, braided and meander, and I will try to give one lecture if possible on the tectonic geomorphology part, where we can utilize the importance of the different channel patterns, straight, braided and meander, and how they change over from one to another depending on the change in the base level or change in the slope gradient, or we can say the river profile. Other than that, we have another one is the basin, that is drainage basin. Usually we take into consideration and different type of drainage pattern. So basin, drainage basin is will be consist of the main stream and the tributaries, and within the main basin you will have the sub basins also, and the drainage divide usually has been marked where we have a slightly elevated portion which separates the flow and direction of two drainages on either side, and those drainages are contributing to the different drainage basins. So this is what has been shown here. So this portion is your drainage divide, and you have the drainage streams flowing in different directions to respective drainage basins. And this also shows the major drainage basin is marked by this yellow line, and then red shows the sub basins or the sub basins which are related to the tributaries. Now, as we have discussed about the terraces and all that, so this is what we came across on a beach in Andaman. So water was coming in, and there is this beach area where the tidal water comes in and goes back, and it has a slope break here. So how the landforms are being formed, this you can visualize on a miniature scale. So you have a meander here, so this is an erosional side, and then you have the depositional side here, and at the same time there is an incision which is going on, which has resulted into the formation of terraces. So this is terrace 1 here, terrace 2 here, and then finally the top one here. So at least we have T0, T1 and T2 here on the depositional side. At the same time, what we see is that where there is a slope break or the break in the slope, you have the incision is more here, and the channels are getting distributed, and we have in between marked by on the braid bars. So these are all channel braid bars. Close up of that, so you can see the terraces here and the incised channel in this location here. Now further looking to the drainage, one can classify the different type of drainage. So one is your consequent drainage and subsequent drainage. We see in the consequent drainages, mostly the consequent drainage will be they follow this the slope developed initially because of the sudden tectonic uplift. So the streams which will develop on the surface will follow the slope, and in terms of the subsequent drainage, it will not exactly follow this slope, because the slope here is if you take the fold here, then the slope is in this direction as well as the slope is in this direction here, but the stream is incising across the slope. So the stream that develops later carved the softer rocks and flow almost right angle to this original slope. So the main difference between the consequent stream and the subsequent stream is that they follow the slope, and development of the slope may be because of the sudden uplift, whereas here there is a subsequent stream which follows almost at right angle to the original slope. Then we have also the term called as antecedent streams. Now antecedent streams are those which will cross across or flow across the uplifted part. Okay. So they are capable enough to erode the uplifted area. So for example, if we are having the folds which are in the developing stage due to ongoing deformation, then the stream which is flowing in that area will be able to cross incise and flow through the uplifted portion. Those streams are termed as antecedent streams. And then another one is your superposed streams, which are the streams where the underlying rocks with different lithologies have been seen, and they will flow in direction eroding the flat-lying surfaces or flat-lying strata as well as inclined strata. So these have been termed as the superposed streams. Another important part which usually we come across, because the drainages usually has been seen developed, like you have a slope, then the streams will, or the drainage will keep developing in the headward direction. So this is the pattern where we see the development of the basin will be, because stream will keep adding from the headward side. So the basin will extend towards the headward side. Okay. So we usually say that the basin developed towards headward side. Okay. So if you are having, for example, the basin which is adjacent to this, then sometime this erosion, because it is eroding it in the headward direction, then it may breach the other streams or the basin and will capture the other basin, and the water flows in that basin. So basically what we see is that through rapid headward erosion, a stream may breach the divide. So if you have a divide here, for example, and then you are having another divide. So another important aspect what usually we come across in the landscape, fluvial landscape, is what we call stream piracy. Now the drainage, and if you recall the first two slides where we were talking about the divide here, and the streams are flowing into one basin, and here the streams are flowing in another basin and meeting the main stream. So this becomes your drainage divide. Now the drainage usually evolve towards headward side. So due to headward erosion, the basin is that is your drainage basin will evolve. So you have one stream here, then it will second, if you see, then it will keep on adding here like this, and then further it keeps going up. Okay. So you have the addition of the drainage or smaller by smaller stream, and you keep developing that. Now suppose you are having a slope that you will understand in the next slide. Okay. Suppose you are having a slope, this I am putting profile here. So if you see this one here like this. Okay. So you have the streams flowing along the slope. So you have these streams which are going like that. Okay. and then here the streams are flowing in this direction, because the slope is in this direction here, the slope is in this direction here, and this will mark your drainage. Take into consideration the headward erosion and the drainage basin evolution, then what will happen, that this will keep eroding this side, and the time will come this will connect, okay. And that what we call is the stream piracy, or even we call this as an stream capturing. So the whole drainage basin will be captured by either of one basin, and then we will have the flow getting into the one single basin. So this usually happen where you have the erosion is going on and erosion is high in the region. So such features are also important in understanding that how the drainage basin evolved and whether there was any sudden change in the overall flow patterns of the respective drainage basin. Through rapid headward erosion, a stream may breach a divide intersecting another channel and capturing its flow, or stream capture is the interception and diversion of one stream by another stream that is extending its basin by erosion in the headward direction. So it keeps eroding towards the headward direction, and finally it will reach to that extent that it will capture the stream. Okay. So diversion of the flow in new channel may leave a vein gap along the ridge. So this one can look at in terms of the vein gaps if they are available. So suppose you are having an uplift going on here. So this is basically the drainage divide over this part, and as we were talking about that the drainage will evolve in the headward direction. Okay. So the time will come, it will breach and it will try to capture the whole drainage from the side. Now other than that, what we also look at is the drainage pattern and the channel morphology. So I will talk about a few examples from this portion, that is again in the northwest Himalaya in Punjab region, and this is Hoshiarpur, and the feature which you see here is the Janauri anticline, and you can easily mark the drainage divide which goes like that. Okay. So this is the top ridge line and the slope in different in opposite direction. So this drainage are flowing like that, and the streams are flowing from here in this direction into the Indo-Gangetic plain, and this is the major streams. So we'll see what drainage has to tell us about the subsurface topography. So what we found was that, of course, there is a very sharp distinct geomorphic boundary here which marks the anticline and the Indo-Gangetic plain, and as we were looking in the previous slide that we have the drainages flowing in this direction and this direction here, and this is the ridge line. But in this portion what we found is in the area which was devoid of drainage, and which is when we moved in field, it was as good as flat area which you see when similar to the Indo-Gangetic plain. So our interpretation was that this whole area was uplifted and very quickly in a very short time, which did not allow the stream to flow through, or the river, major river, because Shatluj flowed through this area here, and this was the remnant of the Paleo Shatluj which was connected through this and flowing through this area here. So this is our interpretation. But because of the rapid uplift of this area, it did not allow, or Shatluj was not able to cope up the uplift, hence it took the turn or deflection, and it started flowing through a gap which was available, and this area is now left out as in flat uplifted surface. So, because of the devoid of drainage here, we were able to pick up that this is a flat area, and that what our interpretation supported when we looked at or identified the paleo channel here. Now, similarly, if we look at in this portion we were able to see that there is a very distinct drainage which is flowing in all direction here. Hence, we interpreted this as a warp area. So, if you are having suppose a slope like this, what you find is that you have the streams flowing in either directions. Okay. So, this becomes a sort of the warped area or deformed area. So, this also it helped in identifying that what are the features we see on the surface and what the drainage has to tell us about the subsurface features. Another important part which we were able to pick up from the drainage itself, that we found some wind gaps, okay. And this is from central Himalaya. This portion is this city is Ramnagar, and Nainital sits somewhere over here. So, what we found was that this drainage which is right now flowing from this portion earlier flowed through this one, because this marks the wind gap here, and then later on it shifted its course here, then further here, and then finally it is flowing here. Okay. But later in future, if there is a tectonic moment along this fault line, then it may go and merge the main Kosi river. This stream is a Dabka river, and this is Kosi river. So, this also one can interpret and identify that what has happened in the past and reconstruct the tectonic geomorphic history of any region. Okay. So, this is the close up of that, which you can see the stream is has left out the remnants or the paleo channel of what we have marked as a wind gap. So, we marked as a wind gap 1, wind gap 2, wind gap 3, and then finally it is flowing here. And similarly, in one of our research article, we have also tried to highlight that there was another stream which used to flow and has left out the wind gaps in this area also, and that was Bore river. So, again coming to the northwest Himalayan part, what we did was we quickly extracted the drainage using SRTM data, and the dark blue lines are showing the higher order streams or the main drainage or the main trunk stream, and the smallers are all tributaries. So, as we were talking about that, we can easily mark the drainage divide if we carefully take into account in which direction the streams are flowing. So, this stream, for example, is flowing and joining this main stream here, and these are all streams which are flowing in this direction. Okay. So, this portion becomes your, and then this portion is your drainage divide, whereas this portion is not occupied much by the drainage, and this is your flat area. So, one can also take into account the drainage pattern and try to identify what type of structure is sitting subsurface. So, this clearly marks that this portion is an folded area. So, if you take the cross section here, then you will find that this is something like this. Okay. So, you have the slope in this direction, you have a slope in this direction. So, you have different type of drainages and drainage pattern, which if you take into consideration like dendritic pattern, radial pattern, trellis, and rectangular. So, how and what is the importance of this, and can we interpret the subsurface lithology or the structure based on this? Okay. Now, a rectangular drainage again will be seen in the areas which are having very typical fractures because of ongoing deformation, and they will flow almost at a right angle. And this will be seen in the area where you are having homogeneous material, whereas the radial drainages will be seen in the area where you are having either volcanic cone or any domal structure, whereas trellis pattern you will be seeing where this main stream and the tributaries will be joining at almost right angle, and this type of drainages are seen in the areas where you are having softer rocks and the resistive rocks. So, mostly in the folded terrain you will be able to come across and find the trellis pattern. Now, as I was talking about that, we did some studies in this area and tried to look at that what exactly the drainage is telling us about the landform. Okay. So, this is the map of this portion here from this area. This is the area which has been covered in this map. We can see here this one. Okay. And this is the exit of Shetland, which is coming here. This is the portion, and up to this one here. Now, what we found was this region was showing us the streams which are flowing in all directions, and we were not having an idea that why it is showing so, because this usually should have been a flat area, because this is an area which is similar to the Pinjore Dune. So, Pinjore Dune is a flat region, almost flat valley between the two mountain ranges, that is what we call intermountain valley, and Dune is the term which is locally used for intermountain valleys like Dehradun, Pinjore Dune and Son Dune. So, we expected that this area will show flat surfaces, but this portion which has been shown here showed us that this is not exactly flat, but we see a sort of a radial drainage here. And then we also picked up some anomalies of in the channel pattern over here, which I will show in the next slide. So, we looked at the lithology. Of course, it was an old deposits of tertiary age, and then when we looked at the high resolution photographs of particularly this area, this portion, and then what we see here is that the drainage here is showing a typical radial pattern. So, definitely this area should be showing a warped surface in the field. Okay. And then second one, we'll come to that. So, first this was the warped area. So, we marked a fault here that was responsible for deforming this surface. Okay. So, the deformation is like your sigma 1 will be like that, okay, and this area is getting deformed like this. Okay. So, this is the deformation. Okay. So, and this line which is also marks the present day road. So, when we looked at this in 3D, we were able to identify a very distinct change in elevation. So, this side is up and this side is down, and this portion we marked as an fault trace. Okay. Now, further when we looked at this one, what we found was that in the portion which is uplifted, okay, the drainages are showing very tight meander, whereas it comes in the downthrown side or the footwall side, then the drainage becomes almost straight. So, this is the portion here. This portion in the next slide I will show, and the close up of this, if you look at this portion, then you will be able to make out this clear demarcation here. Okay. So, this is the line, fault line which goes here, and the drainages which are on the upthrown side is tightly meandering, whereas this portion is almost straight. Okay. So, this again is showing very tight meanders, whereas this portion is almost straight. And then we looked at the warped area in field. So, we were able to pick up very clear and distinct topography which was showing the warping here at Dana. Now, drainage pattern usually tells us about the underlying geology. So, quickly we can look at this one. So, the dendritic pattern which is and very irregular branching tree-like features and common in massive rocks, or we can say that where we are having mostly the homogeneous geology. Parallel drainage again are very much similar to what we are talking about, the consequent drainage. They will develop on the parallel to the slope. Then we have the radial patterns which indicate that there is an elevated portion in the center, and that has allowed the drainages to flow in either directions. Okay. And then we have rectangular drainages commonly seen in an area where you have fractured or jointed rocks, and they are almost at a right angle along its bends. Then we have treeless patterns. So, these are common in area where outcropping edges of the folded sedimentary rocks, both weak and strong, are seen, and mostly the tributaries will be at almost like a right angle to the main stream. And then annular patterns are nearly circular, slightly similar to your radial pattern and all that. Now, this all like understanding of drainage network or drainage pattern or channel pattern you can use to interpret the subsurface area, and if there is sudden change in the drainage pattern or there is sudden change in the channel pattern, one can interpret in terms of the tectonic deformation, or it could be related to the climatic change also. So, one has to be careful while talking about this. Okay. So, I will stop here, and in the next lecture we will continue on coastal landforms, but before that I will try to quickly talk about the tectonic geomorphology part if time permits. Thank you so much.